So by calculating the value of elasticity, economists can categorize the demand for goods according to how sensitive consumers are to price changes. Remember that the elasticity of demand is equal to the percentage change in the quantity demanded divided by the percentage change in the price. So the larger the elasticity, the greater the percentage change in quantity demanded relative to the percentage change in price, and the stronger the response to a price change. We can specify whether demand is elastic, inelastic, or unit elastic depending on the value of the elasticity. Now, remember, although elasticity has a special meaning in economics, don't let the term intimidate you. And a lot of kids get scared when they hear the term elasticity because they don't really understand it, and it's a complicated word, and so it frightens them. Elasticity is all about responsiveness. Later in this course, we'll mention the elasticity of labor demand in addition to the elasticity of consumer demand for a good. These terms merely refer to how responsive labor demand is to changes in the wage and how responsive consumer demand is to changes in the price of a good. If the response is large, the elasticity is large. If the response is small, the elasticity is small. So we're measuring responsiveness. That's what elasticity is looking at. Now, if the elasticity of demand for a good is greater than 0, meaning that the quantity demanded changes by a larger percentage than the price, then demand is what we call elastic. That is if it is greater than 1. Demand is said to be elastic. When demand is elastic, consumers are particularly responsive to a change in price. In our earlier example, a 10% rise in the price of chocolate bars caused a 20% drop in the quantity demanded, and the elasticity of demand was 20%, divided by 10%, which equaled 2.0. Since 2.0 is greater than 1, the demand for chocolate bars was elastic. One of the reasons why demand can be elastic is that there are many substitutes for the good. With the many alternatives to chocolate in the grocery aisle, an increase in the price of chocolate causes many customers to switch to licorice, caramel, or maybe even a banana. So when the price changes by a small percentage, the quantity demanded changes by a large percentage. Now, if the elasticity is less than 1, meaning that the quantity demanded changes by a smaller percentage than the price, demand is inelastic. And on that graph here, it's represented by this line in the table. When demand is inelastic, price changes have relatively little effect on the quantity demanded. Goods that are hard to do without, like medicine and heating oil, often have inelastic demand. The price can change a lot for these goods, but the quantity demanded will change very little. For those who are addicted to chocolate, and you know who you are, the demand for chocolate will be inelastic too. If a 10% rise in the price caused only a 5% drop in the quantity demanded, then the elasticity of demand would be 5% divided by 10% equal to 0.5. Since 0.5 is less than 1.0, the demand for chocolate bars would be inelastic. Of course, an extreme case occurs if the elasticity is 0. In this case, a change in the price has no effect on the quantity demanded. The percentage change in quantity demanded is 0. When the price of life-saving surgery increases or decreases, for example, consumers will probably not change the quantity of surgeries they demand. And that would be an example of a perfectly inelastic demand for a good. The quantity demanded could change by the same percentage as the price. In that case, the elasticity would be equal to 1.0. And demand would be said to be unit elastic. Demand that is unit elastic is an in-between case, in which demand is neither elastic with an elasticity greater than 1, nor inelastic with an elasticity less than 1. This table right here summarizes the three different types of elasticity of demand. And you can see each one, what it means, examples of that, and why the elasticity has that value. This would be a good chart to copy into your notes and to spend some time studying. Now, one way that economists and business owners use the elasticity of demand is to predict the effect of price changes on the amount of money spent to purchase a good. Because many of you are probably wondering, well, why do we even care about elasticity of demand? Does it even matter? And the answer is, if you're a business owner or you're in business in some way, yes, you care very deeply about knowing what the elasticity of demand is for your good, because it affects the amount of money that you can bring in when you sell your good, whether you raise your price or whether you decrease your price. The total amount consumers spend on a good is also the total revenue received by firms. For example, U.S. consumers spent about $25 billion on video games in 2010. Each dollar spent by consumers on video games is a dollar of revenue for the firms that make and sell games and consoles. So in 2010, these firms received about $25 billion in total revenue from selling the games in the United States, the same amount that consumers spent on them. Now, we can use information on the demand curve for a good to calculate the total revenue that would be received for that good, or equivalently, the total spending on the good at any price. To find the total revenue at a particular price, we multiply that price by the quantity that would be purchased at that price. So let me go back to the previous screen here. And remember the formula that we looked at in class. We said that total revenue equals price times the quantity that is sold. And we can abbreviate this by saying TR, which is equal to total revenue, is equal to price, which is P, times quantity, which is Q. So there's our formula. Now, if we go to the next figure here, let's look at some hypothetical examples, some hypothetical demand curves for slices of pie, potted plants, and bottles of soda. At point A in each panel, the price, notice, is going to be equal to $4 in every single panel. Now, at point A in each panel, when the price is $4, we can see that 100 units will be demanded. And so that's point A. The total revenue received for each good at a price of $4 is $4 times 100, which is equal to $400. This total revenue is represented by the area of the green rectangle in each graph. So let me clear this so that you can see that. So this is the green rectangle in each graph, and the area of that green rectangle will represent the total revenue of the firm. The area of a rectangle, remember, is height times width. So to find the area, we take the height of the rectangle, which is $4, and we multiply it by the width, which in this case is 100. And that gives us a total revenue of $400. Now, what happens to total revenue when price rises by, say, 25%? On the one hand, the rise in price means that people will spend more on each unit that they buy. If the quantity demanded stayed the same, this would cause total revenue to rise along with the price. On the other hand, with the higher price, people will also buy less. The drop in quantity demanded takes away from total revenue. So the 25% rise in price could make total revenue rise or fall. So which is it? The answer, as you are about to see, depends on the elasticity of demand for the product. So let's start by considering how a price increase affects total revenue when demand is elastic. Consider panel A of this figure, where the demand for pie is elastic. As we move from point A to point B on the demand curve, or on the graph, the price of a slice of pie rises by 25%, from $4 to $5. The quantity demanded falls by 50% from 100 slices of pie to 50 slices of pie. What happens to total revenue? Well, the relatively large drop in the quantity demanded will take more away from total revenue than the rise in price adds, so total revenue will fall. It falls from $4 times 100, which equals $400, as represented by the green rectangle, to $5 times 50, which equals $250, as represented by the blue rectangle. So this one right here, that's going to be the new revenue. As expected, because demand is elastic, the rise in price makes total revenue fall. Now, why is that? You can see here that what we lost, the revenue that we lost is represented by the green rectangle. The revenue that we gained is represented by the blue rectangle. And so the area of what we lost is greater than what we gained. And so as a result of that, total revenue will actually fall. Now, what if demand is inelastic? Let's look at panel B. As we move from point A to point B, in panel B, the price rises by 25%, again, from $4 to $5. But this time, the quantity demanded falls from 100 to 90, just a very tiny amount. It's a drop of only 10%. After all, potted plants have few close substitutes, unless you like plastic plants. The fall in the quantity demanded will thus take away less from total revenue than is added by the rise in price. Now, how can we see this? Well, the total revenue that we had before is this area right here. But now, total revenue is going to fall. Well, how much is it going to fall by? This area right here. How much will we gain? This area right here. The area of what we gain is greater than the area of what we lose. So now our new total revenue is this area right in here. So total revenue always increases as the result of a price increase when demand is elastic. The increase can be seen visually by comparing the blue rectangle representing total revenue at the higher price to the green rectangle representing total revenue at the lower price. Now, what if demand is unit elastic, as in panel C? This shows unit elastic demand for soda. As we move from point A to point B along the demand curve, the price also rises from $4 to $5, and the quantity demanded falls from 100 to 80. The higher price adds just as much to total revenue as it takes away. So total revenue remains the same. Well, how do we know this? Well, this was our total revenue before the price increase, right? And so once we increase the price, we take away this area, we add this area, but the area of what we take away is the same as the area that we add. So there is no change in total revenue. Visually, we see that the green rectangle showing total revenue at a price of $4 is the same size as the blue rectangle showing total revenue at a price of $5. As always, total revenue remains unchanged when the price changes for a good with unit elastic demand. Now, although we have used a simple formula for the percentage change that suggests a 25% price increase and a 20% quantity decrease in this example, a more complicated formula indicates that both changes are 22.2%. So, if we have changes in total revenue with elastic demand, the price increase equals a total revenue decrease, and a price decrease will equal a total revenue increase. And that's, again, represented by panel B. But what if we have inelastic demand? Or I'm sorry, that was panel A. Inelastic demand, we have a price increase that would lead to total revenue increases, while a price decrease would lead to total revenue decreases. And that would be represented, again, by panel B. We can have constant total revenue with unit elastic demand, and that means with the price increase, total revenue will remain unchanged whether it increases or decreases, and that's represented by panel C. So this table here summarizes the effect of a price change on total revenue for different types of demand elasticities. We've discussed what happens to total revenue when the price rises, which is summarized in the second column of the table. The third column of the table tells us what happens when the price falls. Notice that for each type of elasticity, total revenue changes in the opposite direction when price falls compared to when price rises. For example here, when demand is inelastic, a drop in price, represented right here, won't increase quantity demanded by much, so total revenue will actually fall.